So if I would like to see the formatted equation, I can see the conversion factor here. And I know that the power is 45. Now, if I would like to have, I will wait a little bit. I think that we know is that T1 equals 310, T3 equals 1123, I believe. We need to go back to the previous problem and see that it's 2100, sorry. Now, we should take care here, because if we press in unit system, we will see that the temperature is expressed in Celsius, so it will be literally Celsius, so I will change it to Kelvin. So they know, the program knows that these degrees are in Kelvin. And I think that that's it. So we are going to use ideal gas for air. So we're going to start by defining the states. Oh, we also know that P1 is 98 kilopascal. And again, if we press here, we know that the pressure is in kilopascal, so we are okay. So we are going to start by saying state 1. And what we can do in order to keep track on everything is move both states here. And then immediately compute the properties that we need. So thermophysical units, ideal gases, air, and what I like to have is internal energy. And internal energy is only a function of T. We should suspect, because in the table the only entrance was T, the temperature. And similarly, we can get the volume one, because we know that we're going to need it. We can get the volume 1 because we know we're going to need it in order to compute. And this volume is function of pressure and temperature, since it follows ideal gas law. Since we are going to define an isentropic process, we are going to also compute entropy. Entropy 1 is a function of T1 and P1. So we can press F2 or the little calculator to see that we are solving. It mentions that we have 3 potential unit problems. We can address that later on. So we have state 1. State 2, we know that the process 1 to 2 is isentropic, so S1 equals S2. Because of that, we know that volume 1 over volume 2 equals R is the compression ratio, and then we can compute V2 as the volume using but we're going to change this we don't know temperature, but we know that S1 equals S2, S equal S2 and P equals P2, but we don't know P2. We can change temperature and temperature, which we don't know either, but with these two properties, state useful design, so we can find out S2, which we already know, it's equal to entropy per T2 and V equal V2. So we press F2, we have a warning, but we got it, and we can see that it's the same result that we have in our problem. So we have S2, and we can compute the internal energy. For state 3, we're gonna copy all these equations. We don't need volume. Oh no, we do. When we say V2 equal V3, and here we can say search and replace everything that's a 1, we're going to change it with a 3. Place all, and we press F2. We notice that we are missing one equation. We can check we don't have P3, so we can so we are going to change this value of P for property that we do know, which is volume. So finally we go to state 4. And in this state, it's time to copy, to write it as 3 equals S4, which is isentropic expansion. Since V2 equal V3 and V1 equal V4, we can just copy this equation and change volume 4, T4, and S4 that we already know. And we also going to copy this equation for internal energy we should have all our properties. We check that that U4 is similar to what we have, 764, and now we can introduce our expressions. For instance, W in will be U2 minus U1, W out will be equal to U3 minus U4, and Q in will be equal to U3 minus U2. Now W net is equal to work in, work out minus work in. Remember that all of these expressions we already derived in the previous video. So from here we can get at a thermal, which is the efficiency, W net divided by Q in, I would say already times 100 to get in percentage. And we are missing something again. So we check that we are using H3, which doesn't exist. This is clearly a mistake, so it's U3. So we need to change. And we're good to go. We see that the efficiency 52.2. We're gonna put this thermal as subindex. Oh, it's already there. So we can now introduce the formula for the for mass. Mass will be equal to V over V1. Remember how do we call this volume? We call it volume 1. I'll change this to Vmax so we don't have conflicts, because it doesn't differentiate between capital and lower letters. So this is V1 and this is max. So if we press F2, we see that we have the same value. So we are ready to introduce our expression. We don't need to solve for n equal to the mass of each cylinder times the number of cylinder times W net times n divided by 60 times 2. If we press F2, we have that our n is 4,586, which is very close. We can do two things like highlight these results in a box with different color and with yellow. Okay, so now going back to the problem, it says that we would like to see the effect of the compression ratio on the network done and the efficiency of the cycle, and plot the PV and TS diagram for the cycle. Okay, so in order to have the plot, we need to create a parametric table. In the parametric table, we are gonna change the compression ratio and plot the efficiency. We're going to plot network. I think that we didn't choose, so we are gonna start insert variables. Okay, so it says program sets from 5 to 11, so we can just introduce them. We are familiar with this. First level 5 to 11. If we try to solve it, it will check that we already have a value stated, so we need to put that value in comments. And press F3. And we can plot. We can add a second variable. Let's do that first. Insert variables, and I will add efficiency, since it's something that I've been asked to. So you can show the results here. And now I can plot, and I will plot XY with RC versus delta init. Automatic update, add a legend, blind fit, and I will use this symbol. So I have network. See that this going up, very similar to the figure that we see in class and in the videos. Now I'm gonna overlay in this plot eta, but I will do it in a different scale, the right scale. And again, I will add automatic update. And I see that efficiency is also growing. So that's the first part. Now, second plot that we are asked to get is the property plot. We need to do the TS and PV diagram, so we're going to create a couple of, we're going to do it with the TS. You are required to do it with the PV and see what problems you might have. So I'm going to plot a property plot, and I will do it for air on a TS diagram, and I will take out the units of volume. Sorry, I'm gonna leave them, and just so this is my graph. Now, if I want to overlay this plot, I notice that I can use a parametric table, and that's it. But in my parametric table, I don't have these results. So what I'm going to do is convert my results to an array table. So we can do it. We can do it like T1 equals T1. These brackets show that they are an array table, so T2 equals T2, T3 equals T3, and T4 equals T4. We can do the same thing for S. S1 equals S1, S2 equals S2, S3 equals S3, and S4 equal S4. So if I press F2 again, I need to take out the comment, otherwise it will not solve it. I notice I have a new table, which is an arrived table. So I can overlay this plot. So plot, overlay plot on the TS diagram. I will overlay the array table. In the x-axis I will use entropy, in the y-axis I will temperature, and I'll change the color. I'd have a red one, and I will put an automatic update. So we are missing line 41. We can do trick and to make 1 equal to 0.5. So you go to the end, and we can create S5 equal S1, and do the same with the temperature. Temperature 1, temperature 5, and if I press F2, I need to update the table, and I have it complete. Notice that this line should be follow this curved line, which will be a constant, or at least have a curve, but it is not interpolating, or is not following that. It's just putting a straight line between these 2 points. Okay guys, I think that's it. We can save our problem and finish. Things that we can do, we can start thinking on different temperatures, different pressures, different initial conditions, speeds. Let's say that I would like to change the number of cylinders. This will not change because this is per cycle. So let's find out if this changes to 6. You can see that this is the same, and if we go to the solution window, you will see that the efficiency is the same, but the speed decreases. Okay, well guys, this is it. Next video will be for the diesel cycle. Thank you. Bye.